What are event dispatchers and why are they so important when making scalable systems? By the end of this video, I hope to give you an answer to both of those questions, as well as some ideas for how you could implement them right now in your current project. So first off, what problem do event dispatchers solve? Here on screen, you can see an example of a health component. Its only job should be to manage the health of whatever actor owns the component. But right now, when the actor takes damage, the component checks to see if it should die, updates the health bar, plays a hit effect, and calls a function on the player. That's a lot of direct function calls that don't necessarily have much to do with this specific health component. If we wanted to reuse this component on multiple types of actors like enemies, the player, or maybe some breakable crate, we might not always want to call a function on the player. Some of those actors may not even have a health bar or use the same hit effect at all. That quickly becomes a scalability problem for us. So how do we fix that? Instead of directly calling every system that might care about the health changing, we create an onHealthChanged event dispatcher and simply call it whenever the health changes. Then any other system that needs to know about that can bind to the event dispatcher and decide for itself how it wants to respond. So what exactly is that doing? Imagine you're getting ready to play a game with your friend, but they aren't online yet. Most people wouldn't sit there and stare at their Discord profile and check every few seconds whether or not they've come online. That would be pretty weird. Instead, you say, hey, let me know when you're online. When they notify you, you respond by launching the game. That is basically how event dispatchers work. You bind a response to an event you care about. When the blueprint responsible for that event calls its dispatcher, every bound listener is then notified. More directly, an event dispatcher allows one blueprint to announce that something happened without deciding what other blueprints should do about it. A listener subscribes to that event, then runs its own logic whenever the dispatcher is called. Let me show you exactly how this is done. Here in this health component, we're going to delete all of these direct function calls. Then in the My Blueprint panel, we will add a new event dispatcher and name it onHealthChanged. A quick note on naming. Event dispatchers typically use the on prefix, and you want to name them after the event that happened rather than the response you expect. Update health bar would be a bad name because it assumes what the listener should do. onHealthChanged describes the event and leaves the response up to the listener. Now that we have the dispatcher, we'll probably want to pass in some useful information to our listeners. Let's add some float inputs for old health, new health, and max health. This gives every listener the important information without making them separately ask the component for the same values. Now all we need to do is call this event dispatcher at the end of our take damage function. We make sure to store our old health before changing it, then plug in the old health, new health, and max health into the call node. At this point, our health component is successfully announcing that its health has changed. Now we just need to bind to that event from any system that wants to respond. For this example, we'll go to our health bar widget. Previously, our health component directly called this update health bar function. Instead, we're going to create an initialize health bar function with a health component reference as an input. The system creating this widget can pass in whatever health component the health bar should display, whether that belongs to the player, an enemy, or a boss. The health bar no longer needs to cast to one specific character just to find its health. Inside initialize health bar, we'll store that health component reference and use assign onHealthChanged. Assign automatically creates a new custom event with the same signature as our dispatcher and binds it for us. Now we add whatever functionality we want inside this listener. For this example, we'll set the percentage of our progress bar using new health divided by max health. There's one important detail here. Event dispatchers do not store or replay previous calls. This health bar only hears calls made while it is bound. Because of that, we'll update the health bar once during initialization using the component's current health. Then let the dispatcher handle future changes. And just like that, our health bar automatically updates whenever the health component's health changes. Now let's add a second listener so we can see one of the biggest advantages of an event dispatcher. We'll go to our player character, get its health component on begin play, and bind another event to onHealthChange. Because onHealthChanged can also be called when the player heals, we'll compare new health against old health. If new health is lower, we know the player took damage. For this example, we'll just print player took damage, but this could play a camera shake, a damage effect, animation, or any other feedback specific to the player. Now when the player takes damage, our health bar updates and our player character responds at the same time. The important thing is that we never went back to the health component to add another direct function call. It still broadcasts one event. and both systems independently decide how to respond. Instead of assign, we could also use bind event. Assign is a convenience node that automatically creates and binds a matching event. Bind gives us more manual control. We can connect a compatible custom event or use create event to select a compatible function. Either way, its signature must match the dispatcher. Assign is typically just a little bit quicker when creating a new listener. This can also make UI updates more efficient. Often you'll see developers bind a UI property directly to a value like this. Those property bindings are generally evaluated every frame while the widget is active. With our dispatcher, update health bar only runs when the health changes. The benefit doesn't come from dispatchers magically being much faster than function calls. It comes from replacing constant polling with a notification instead. So you might ask, how many listeners can bind to the same event? The answer is simple: as many as you need. The dispatcher doesn't care who is listening or how many listeners it has. You can even have no listeners at all, and it is still completely safe to call. Additionally, event dispatchers are a great way to reduce dependencies, although they don't fully remove them. Our health bar still needs a reference to the health component, so it can bind. The important difference is the direction of that dependency. The reusable health component no longer depends on the health bar, hit effects, player class, or any other potential listeners. We can reuse it without it knowing anything about the systems listening to it. So when do we use event dispatchers? The best scenarios are events or notifications with anywhere from 0 to many potential listeners. Something happens and other systems may want to know without the broadcaster needing to know who they are. Components and UI are two very common places this occurs. Other examples could be on item collected, on objective completed, on settings applied, or a reusable inventory slot broadcasting on slot clicked to whatever menu currently owns it. So when should you not use event dispatchers? Event dispatchers cannot return a response. If some logic needs a return value, such as asking whether an interaction is allowed, a dispatcher is not the right tool. If we already know the exact target and only ever need that one target to perform an action, we can also often call the function directly. Event dispatchers are for announcements, not questions. A good rule is to use them when the sender doesn't need to know what the listener did in response. Let's also say listener B depends on listener A running first. We cannot directly control the order in which listeners are called. What we actually have is one ordered sequence of logic, not two independent listeners. Never make dispatcher logic depend on listener execution order. One other useful detail is that event dispatchers are not delayed or asynchronous. When we call the dispatcher, the currently bound events execute immediately as part of that call. We just shouldn't rely on a particular order between those listeners. Finally, let's talk about the binding lifecycle. For event dispatchers to work, listeners must bind to an event. This is often done during initialization, but you can bind somewhere else as long as the listener is bound before the dispatcher is called. You should also be careful about binding from something that may initialize multiple times. For example, a widget's construct event can run more than once during that widget's lifetime. An explicit initialization function, like the one we created for our health bar, gives us more control over when the binding happens and which component we are observing. We may also have temporary listeners. Maybe a widget only listens while open, or a health bar switches from one actor to another. In those cases, we should unbind from the old dispatcher. The unbind event removes one specific bound event. Make sure you provide the same event you originally bound. Be careful not to use unbind all events unless you specifically need it. Unbind all removes every listener from that dispatcher, including the listeners belonging to completely different systems. That can be dangerous when you only intended to remove your own listener. So that's how we use event dispatchers. They are an excellent way to clean up your code, reduce dependencies, replace unnecessary polling, and to make reusable systems that don't need to know everything that may respond to them. I use event dispatchers constantly in my own games, and you can see that throughout my Build Systems at Scale series. If you have any questions or there's another topic you want me to cover, let me know in the comments. I'll see y'all next time.